Hi everybody, this video is going to cover the third page of the 6.6 graphing notes. So this is the page that has the vertical asymptotes. So we have found that when we look at the numerator, we get the zeros and multiplicity of the graph. And when we look at the denominator, we get the vertical asymptotes and multiplicity. And that's because that's where we look for dividing by zero, and if it divides by zero, that it can't happen, right? It doesn't exist, and so therefore there has to be a vertical asymptote there. Okay, so if we look at our numerator, we have two factors in our numerator. We set each one equal to 0, and we find out what they are. So we get a positive 3 from this factor and a negative 4 from this factor. Then we have to look at the powers, and this one has an even power. And if there's an even power, then it bounces. And the other one has a third power, and if there's a third power, then it bends. I'm going to go ahead and put the plot those on my graph. So I have a negative 4 here and a positive 3 here. If you wanted to write a note to yourself on the graph, you could, or just remember to look back here. All right, now we need to look at the denominator, and in the denominator we have x plus 2 and we have x minus 5. And again, we can't have a 0 in the denominator, so that means that x basically cannot be negative 2 and x cannot be positive 5. So the vertical asymptotes are x equals 2 and x equals 5. So now I'm going to draw a dotted line. Sorry, that was a negative 2. I'm going to draw a dotted line at negative 2 and also at 5. Then I also want to look at the multiplicity. That means the power. So this one has an even power and 5 has an odd power. So I'm not talking about the number itself. I'm talking about the power that's on there. So this is the 2, that's an even power. This one is a 1, which is an odd power, because that's going to tell us how we go with our graph. All right, then also we need to look for the end behavior. And for the end behavior, what we do is we kind of multiply it out, So we have a negative. I'll show you. We have a negative x squared, and then over here we have x to the third. I know that there are some numbers in there also, but we're just going to estimate for this one. And so what we do is we get negative x to the fifth over x to the third. That gives me a negative x squared. Well, what does a negative x squared look like? Negative x squared is a parabola, so it's end behavior. Now, let me tell you about end behavior. It's not gonna have this part here, it's gonna just the ends. So I'm just looking at what's happening on this end, what's happening on this end. And so on the left-hand side, it's going to be approaching negative infinity, down here somewhere. On the right-hand side, it's also going to be approaching negative infinity. And this time I'm talking about way over here, on the other side. Each section of this graph needs to have something in it. And so we're going to figure out where all that stuff goes. So this is my end behavior. These are my asymptotes. These are my zeros. Now another thing we could do, which is not listed on here, but we can do it, is find the Y-intercept, because that actually will kind of give us some bearings sometimes. So remember, to find the Y-intercept, you always plug in a 0 for x and work it out. So I'm going to do that. I'm going to take a second to plug in a 0 for x, work this out. I'm going to have to put it into my calculator and see what I get. Oops. Okay, I plugged it into my calculator, and what I got is a negative 576 over negative 20. And so if I simplify that, that comes out to be a positive 28.8. Okay, what that means is my Y-intercept is up here somewhere at 28.8. It's off the graph, but that just helps me get a little bit of bearings. All right, so now how do I put it all together? To put it all together, I start on the left-hand side, and I start here and I move to the right. And I have a lot of stuff in between, so I have to pay attention to everything I'm doing. So as I go, I'm going to start here, and I know I have to hit this 4, negative 4, and it says that there's a bend there at negative 4. So I'm going to come up here, I'm going to bend it there at negative 4, but then I cannot hit this asymptote, so I just have to keep going closer and closer and closer for infinity. Okay, never touches it, just gets closer and closer. Now, what do I do now? Well, I need something in here, so I have to jump over this line, and because it is, let's look at the power of it. It is a negative 2, it has an even power. An even power means you pick up right where you left off, just on the other side of the border. Then I know I have to go to this 3. And at the 3, there's a bounce. So I'm going to go towards the 3 and, bounce and come back up. Now, you might say, you missed the Y-intercept there. That's true. How could I graph that? I'd have to get way up there and show you that it's coming down here. Okay, so you could do that. I can erase that. And that's going to be a little bit more accurate. Here's the deal. I'm not real concerned about accuracy on the y-axis. It is helpful. It gives us an idea, but there's nothing really that's that important mathematically on that side. So it's going to go something like this. In fact, if you just had it drawn kind of in the middle there, that'd be fine as long as it hits the 3 and it bounces at the 3. All right, now let's go to the other asymptote. This is a positive 5. It has an odd power. Odd power means you have to go all the way over the other side of infinity. So I was up here at positive infinity. That's what my arrow means. Then I have to come down here to negative infinity. Now I have to go somewhere, but I cannot touch that axis because there's no zeros. And I have to end this way. So I'm going to have to turn right back around and come back down this way. Let me show you on Desmos what this looks like. First of all, this as a hand-drawn graph is fine. Mine's quite messy, but you know what? It's fine. It shows me all the detail that I need. If I go look at Desmos, this is what it looks like on Desmos. Oh, kind of crazy, right? Well, look, it has end behavior down here, comes up, hits the negative 4, bends, and goes up to infinity. And then it comes right across here, comes all the way down, hits that positive 28.8, comes down here and hits the 3, 0, bounces, and bounces back up. Then over here, it had to have negative infinity and behavior, and it had negative infinity on the asymptote, and so it came here. So this is my graph. And like I said, this is graphing on a calculator. In addition, you might be able to tell I changed my y-intercept, my y-axis. And when I drew it, this is what I got. It's messy, but it's close as I can get. All right, let's do one more example. Will you take a second to look at this, look at this equation and decide what goes where? All right, if we just take a look at our numerator, we get x equals 2 and x equals negative 3 for our x-intercepts or our zeros. So we can put one at 2, we can put another one at negative 3, and it's going to bounce on both of those because they have an even power, even a fourth power. That still means a bounce. Then, denominator tells us that x is negative 5 is odd power. Remember, it has a 1 there, so that's an odd power. And the negative 1 has an even power. So I'm going to go over here. I'm going to make my graph, my asymptotes on my graph. End behavior. We haven't talked about end behavior yet, so let's talk about end behavior. I have a negative 3 times x to the 4th times x to the 2nd over x to the 1st, x to the 2nd. That's a negative 3 x to the 6th over x to the 3rd. That reduces to negative 3x to the 3rd. I don't really need that 3 in the front, but I do need my negative x to the 3rd. That end behavior is going to look like this. The left-hand side is going to positive infinity. The right-hand side is going to negative infinity. That is what we need to graph. If you wanted to find the y-intercept, you would plug in zeros. I'm honestly just not going to do that right now, but I'm going to deal with the rest of it. All right, I have a positive infinity starting point, so I'm going to have to come way over here to start. But look, there's nothing over here. So I call these floaters. It's just like floating out there in the middle of nowhere. Then this asymptote is negative 5. It has an odd power. That means I go to the other side of infinity. So I'm coming down here, opposite infinity. And it's supposed to bounce off of the negative 3. So I'm going to do that. I'm going to go up. I'm going to bounce off the negative 3 and come back down. Now I'm here at negative, my graph is wrong. Oh no, that's right, negative 1. Even power means I pick up right next to it. It's also supposed to bounce at positive 2. So it's going to come up here. It's going to bounce and come back down. Okay, I'm going to double check it. I'm going to show us. Our end behavior has 1 over here, way over here. It's actually way up here. And then the downside is over here. Stuff in the middle is different. Asymptote, odd, and even. Bounces, bounces. We have everything we need. That's our final answer. Okay, let's fill in a little bit of a summary. What do we do when we factor the numerator? That's how we find the zeros or the x-intercepts. and the multiplicity. And what I mean by multiplicity is if it's a first power, it goes through. If it's an even power, it bounces. If it's an odd greater than 1, it's going to have a bend. The denominator is where we find our vertical asymptotes. Okay, the vertical asymptotes also have a multiplicity, and we look at the powers. It can be an odd power or an even power, and that tells us what side of, basically kind of like what side of infinity to go to. We'll talk some more on that. Now, the number of asymptotes will determine the number of, I will call them sections of the graph, and you have to have something in each section. So, for instance, on this example, I had 2 asymptotes. I had 3 sections of my graph. I had 3 pieces of it, okay? So there has to be something in each section. So the number of sections we have is going to be the vertical asymptotes plus 1. So there's 2 vertical asymptotes, 3 sections. To find the end behavior, reduce the function to its lowest terms and then recall the positive negative infinity rules. So that's what we did over here. Reduce it to its lowest terms, and then you have to remember our end behavior. When you are graphing, start on the left and pay attention to end behavior, because that end behavior is going to tell you where to put that very first arrow and the very last arrow. All right, we have lots of practice in class on how to graph.